Hello Math 10a. I have another worked example problem, this time for section 3.6 on the chain rule. And this is a particularly nasty problem here. We're going to differentiate f of x equals the square root of x plus the square root of x plus the square root of x. So that is a mouthful. This is going to involve two uses of the chain rule. It is going to involve, a little bit of messiness. I think it's always a good idea for you to follow along with these on your own. Make sure you maybe try the problem before watching the video, or at least try staying a few steps ahead. I think that'll be especially useful here, as I'll be maybe making my work a little bit messy in the middle. I don't know if there's a clean way to organize everything you need to do here. So first, let's remind ourselves, what is the chain rule? It's always a good way to start. So the chain rule says if f of x equals g of h of x, then f prime of x equals g prime of h of x times h prime of x. So you take the derivative of the outside function, keep the inside the same, and then multiply by the derivative of the inside function. And one of the hardest parts of using the chain rule is figuring out which things are g and h. So let's just get this set up. Here we can see we have a big outside function, which is the square root, and then something on the inside. So this is going to be our h of x, and then the whole thing is going to be g of h of x. So maybe I'll make a little table over here so we can keep track of everything that's going on. G of x is just the function square root of x. Sometimes, to avoid confusion, because it doesn't matter what letter we write here, it's the same function, so we'll say g of u equals square root of u, and sometimes that indicates that u is itself going to be a function, like h of x. So hopefully that's clear. And then h of x equals x plus the square root of x plus the square root of x. So still not the most pleasant looking function, but that's what we're working with. And now we'll plug into our formula here. So f prime of x equals g prime of h of x. Well, we know what g prime of x is. That's going to be 1/2 x to the negative 1/2. So 1/2, and we keep h of x the same. So inside here, we just write h of x square root x plus square root x, and then to the negative 1/2 power. Right? That's the power rule because this is x or u to the 1/2 power. The derivative is 1/2 u to the negative 1/2 power. So 1/2 u to the negative 1/2 power, the u here being h of x. Again, I said this was going to involve some notation. There's no easy way to say this. There's a lot of plugging different things in different places. So I hope you're following along. And now we're going to multiply this by h prime of x. But we don't know quite what h prime of x is yet. This is still an ugly expression. Definitely is going to take some work to compute the derivative of that. So let's go down here to figure out what is h prime of x. Well, the first part, we can take the derivative of x. That's 1. And then it's going to be times whatever the derivative of square root of x plus square root of x is. And so here, this looks like another chain rule problem. And what I'll do is I'll call the inside bit, I'll call that j of x. And the whole thing here is going to be g of j of x. Okay, so I'll put up here j of x is just x plus square root of x. And so this derivative of this is the derivative of g of j of x. And so that's going to be 1 plus g prime of j of x times j prime of x. Okay? And we know what g prime is, and j prime this time is not going to be hard. No extra chain rules, just a sum of 2 power rules. So we can compute that. So this is going to be 1 plus g prime of j of x. That's 1/2, keep j of x the same, x plus square root of x to the negative 1/2 power, times j prime of x is just 1 plus 1 over 2 square root of x. Okay, which is the same as, that is 1/2 x to the negative 1/2 power. But I'm trying to, as much as I can, keep this in terms of writing things as square roots, because that'll make it look a little bit nicer at the very, very end. Okay, so this is now our h prime of x. So, like I said, it'll get a little bit messy, but let's finish writing our f prime of x all out as one big expression. F prime of x equals 1/2 x plus square root of x plus square root of x to the negative 1/2 power. Okay, that is our g prime of h of x times h prime of x, which is, big parentheses, 1 plus 1/2 x plus square root of x to the negative 1/2 power times 1 plus 1 over 2 square root of x. And now we are done doing calculus. That is our derivative, but I just want to make it look slightly nicer so you can kind of maybe see what the pattern is. So maybe what I'll do to give myself some room is just drag this whole expression down. Actually, before I simplify this, I want to show you maybe another way I would think about doing this problem. So when I'm solving this, I'm not going to be explicitly writing down g, h, and j. I think that's a good way to think about how exactly are we applying the chain rule. It's good to be able to break down a problem like that, but I don't always write that down explicitly. So let me just, I'm trying to see where I have room for this. I'll do it right over here where I had just written it. Walk you through the way I think of solving this problem. So we have, this is our f of x, and when I'm writing f prime of x, I think I have an outside function. To find f prime of x, I take the derivative of the outside and keep the inside the same. So that is 1/2 x plus square root x plus square root of x to the negative 1/2. And then I multiply by the derivative of the inside. Right, so again, this is how I think about solving the same problem. I don't give names to everything, I just think about take the derivative of the outside, keep the inside the same, multiply by derivative of the inside. Derivative of the inside is 1 plus square root, or, yeah, derivative of the inside is, I'm not sure, it's 1 plus whatever the derivative of this is. And then I say, well, what is the derivative of this? Well, that is going to be derivative of the outside, 1/2 x plus square root of x, keep the inside the same, to the negative 1/2. So it's derivative of the outside of this, keep the inside the same, times derivative of the inside, which is 1 plus 1 over 2 square root of x. Okay. So you can see when I think of this, when I'm solving it, I don't write out the g, h, and j and have all this messy work. I can just kind of write it out in one line and make sure I'm keeping track of all the chain rules I need to do in my head. One of the negative parts of this might be that when I'm writing that out and explaining it, it's a bit harder to follow exactly what's going on in my brain, which is why I also did it this way. But I want you to see that you don't always need to write out all of this to solve a problem like this. You can just do it in one line, thinking about each step, being very careful. Whichever way works for you right now, I want you to do it that way. I just want you to know sometimes you don't need to write everything we write in these videos in order to be thorough. And now, hopefully not having confused you too much, I'm just going to take our answer here. You can see it's the same one both times, so I hope you're convinced by that. And I'm going to simplify it a little bit so you can see that, at least from all this work, we have gotten something that looks, moderately nice. So this is, we have this whole bit, 1/2 x plus square root of x plus square root of x to the negative 1/2, so that all of that goes in the denominator of the entire thing. So it would be a 2 square root x plus square root x plus square root x. Okay, so that's our denominator of everything. And now what do we have on top? We have a 1 plus something, so I'll make a giant 1 plus, and now we have some stuff over square root x plus square root of x, and we had a 1/2, so I'll put the 2 in front. So 2 square root x plus square root x. And now on top of that, we have 1 plus 1 over 2 square root of x. Okay, so we have this multi-layered, I think of this almost like a multi-layered cake, giant, ugly fraction. But you can sort of see there is a nice pattern here. If we added more nested square roots into this terrible expression we started with, you can maybe guess what kind of pattern would continue. So, terrible, ugly problem. If you understand this, you probably understand every chain rule problem you'll ever see. I don't think they'll ever get much worse than this one. So, once you've mastered this, I think you're in pretty good shape. And I encourage you to, as always, try it again on your own and make sure you really do understand how to do everything here. And with that, thanks for watching, and I will see you next time.